The optimization experiment is the art of finding the perfect set of parameter values that will maximize or minimize an objective function. But many beginners and even intermediate developers in AnyLogic, they only use optimization experiments without replications. And replications is the idea of running multiple simulations with the same set of parameters to gain confidence about what the results of that set of parameters are. If you want to run an optimization experiment properly in AnyLogic, you need to use replications. If you use the genetic algorithms, you will be allowed to use a fixed number of replications. So for example, 10. If you choose OptQuest, you will be having an option here that allows you to vary the number of replications to reach a confidence level with a certain error percent. But unfortunately, this functionality doesn't work. And this is why we created the optimization library that we are showing you on this video. It is of my opinion that in order to run an optimization experiment properly, you need this varying reps functionality. Why? Because you need to run as many replications as you need in order to reach the confidence with an error that you're willing to accept. And this functionality does this amount of runs automatically, which is, in my opinion, important. Since this functionality doesn't work in AnyLogic, that's why we created this library, to have it ourselves, and now we're sharing it with you. So on this video, we'll show a demo on how this works.
Well, here we are using the optimization library in AnyLogic. You can see the optimization interface first, with one plot that shows the current state of the optimization. But let's take a look at the model we are optimizing. In this model, a supermarket is looking for the best location in an area with several houses. The goal is to place the supermarket, which is this, where it will be easily accessible, especially to households that will visit more often. Using survey data, the owners estimate how many visits each household will make per month. Then simulate these visits over a year using a triangular A/B distribution. The model calculates the total distance customers will travel to the supermarket, and having this information, we can run the optimization with 100 iterations to find the location that minimizes this distance. With 95% confidence, the model reveals the best coordinates for the supermarket. But remember that there is no guarantee that the solution found is the absolute best or global solution, especially if the optimization problem is non-linear. So let's go back to the optimization. Let's click here on Start. We can see the progress bar over here and how we are finding new solutions that minimizes the objective value. For this example, we are conducting 100 iterations, but as well, there are 5 replications for each solution. That's why you are watching here an upper bound and a lower bound. Since the confidence level defines the t-value, the higher the confidence level, the higher error percent we will have. After each replication, the error percent will be calculated and will be compared to the error percent defined in the parameters section. If the error percent calculated is less than the error percent defined, no more replications will be run to not waste time doing more replications than needed. So, in that way, we can optimize based on the average value using the confidence level. And when the optimization ends, we can see here the values for the parameters that minimizes, in this case, the objective function. So we can say that these are the coordinates necessary to locate the supermarket in order to have the minimum distance between the houses. Well, here we are in AnyLogic, and let's see where the library is. So we have this icon, as you can see here, for the optimization library, and we can see some agents. So we have here the Monte Carlo experiment that has its own YouTube video, and for this video we will be discussing about the optimization experiment and the settings. So this optimization experiment is the agent where all the stuff related to the optimization experiment is defined, including the number of iterations, minimum and maximum replications, confidence level, error percent, and the objective expression. There is also an automatic stop in case the optimization is not improving over consecutive iterations. And finally, we have this presentation that is the user interface when running the simulation. And you can always export the results of the optimization clicking on this button. Thanks for watching. Feel free to drop any questions or feedback in the comments below. If you are interested, you can check out all the documentation for this library in the description of this video.